So, guys, first of all, I need to fix this to be correctly all AB, but in general, the schedule for till the exam is May 8th, Monday. Um, and there's this spring break business. You are here.
There's Play-Doh.
Yeah. What? We'll get there.
Is that like that? Like,
You don't actually get to play with the Play-Doh, but
wow.
I know. So, it's really known as finding volumes of known cross sections. It's much less interesting. Yeah, but that's kind of false advertising, so I should probably not call it that. But anyway, Chapter 7. You have a test on Chapter 7 next Wednesday. And so things in Chapter 7 are like 7.1, which was net difference, net versus total. Your total change of running around back and forth, you ended up 3 feet from where you started. That's displacement. That is just integration. Water was coming in, water was leaking out. The integration of the thing overall is how much water changed over the course of time. 2 gallons more, even though it was leaking. Then today is, I call them Play-Doh. That's the things that are around the room, these 3D objects.
Oh.
Like these guys.
This really is false advertising.
Yeah. So that's today and tomorrow. Then we will have, and we did area between curves already, but we're also going to do area between curves, and we're going to spin them. Spin them this way, and they can also spin this way, and they can spin and make holes and things that are drilled out. Carson, it'll be total fun.
Yay.
Yay! Yeah. So.
What about like that?
Yeah. That's Play-Doh. That's not a spin. I will show you. But visually, I have a 3D emulator on my calculator. You guys do not. Yes, Jesus does that. But fourth quarter, the things that count in your grade will be 5 pieces. Really, it's 4 tests, but it's going to be broken into 5 pieces. There will be free response. So you will take over the course of several days an actual AP exam, and that will be your fourth quarter grade. The nice thing about it is it's on the AP curve. So a 5 for the AB exam, looking it up, is more like a 62%, not the 58% as a BC. I know, a low D, and it's like roar 5. So the free response questions, there's 6 of them. I hate them because I have to grade them. They suck. But this is what we've been doing every Friday, like trying to practice these. And I'd like to say they're getting better, but I'm not totally sure. There's flashes of improvement, and then it's like suddenly like no. But 1 and 2, you get to use a calculator. 3, 4, and 5, you don't. And then there's multiple choice without calculator. That's the one I need a 1-hour time slot for you guys to do. So I'm going to ask if there is a day that is less painful to stay an extra 15 minutes after class. So, and it can be any day from the 11th till, like, it could be any day in here. I love that day because I take the little things and I go skipping on down to the Scantron. I go, and they're all graded, and I come skipping back and I type them in. It's a beautiful day. Of course, last time the machine ate them on like the 3rd one, and everybody else is like. So I still have dreams that one day it will work correctly. Thank you for laughing at me. That's great. Love to hear it. So, Any particular day that's better or worse for
Fridays.
Fridays are good or Fridays?
No one does anything on Friday after school.
Here, Maya. What are you talking about?
No, not
Clubs
Fridays.
don't happen on Fridays after school.
Okay, that's
Anything
you.
on Tuesday or Thursday.
That's you.
Monday, Wednesday, Friday.
Everything happens. Listen, everything happens in the middle of the week, and no one wants to do anything on Monday. So Friday. You know,
No,
that's
it's
That's
not Friday.
completely not good.
You know, actually, that's not the worst take now that I'm thinking
Okay.
about it.
I will
Why don't you just send something around this house?
I will send a Google form and I will give you options. But how many of you are in band? You doing the band trip? Yeah? Yeah? Yeah.
Of course.
Chorus,
Not that.
music, okay. Because the free responses that are that day, I'd like to leave it on that day because grading these sucks, but I have then 3 days to do it. So, but again, that test can be taken anytime during class. I can send you in the hallway with Daniel or whatever, and you can sit out there and do your test.
What's on April 11th, 12th,
Review of stuff, like,
back
There's-
to the beginning?
well, so to show you the review books and, well, I should hand those out this week as well. But, it's to do, review from the beginning and like strategies about the AP exam and their instructions, which if they don't tell you, how do you round?
3 days.
3 days.
3 decimals, thank you. Can you just chop it off at 3 decimals or do you have to round or
Just drop it off.
you could do either one?
What's
Okay.
on April 14th?
What's on April 14?
As we're
Topics, recap, and strategies.
Yeah, so, and I haven't copied them yet, but 2008 has been released and I might have it in the books for you. So, and the binders that I have for you, please don't write in them. I'd like to use them each year, so get scrap paper out and do stuff elsewhere. Yeah. So anyway, there's that. And look,
Make that go back.
isn't this just so fun? This is just one
I
question.
feel
Please make it go
attacked
away.
looking at that.
Just please make it go away.
I'd like to
I
speak with my
forgot about
counselor.
those.
On mission
I mean, that is one question.
for us.
And in BC Calc, this is the dreaded chapter 9.
Okay, but that's not for
Unless
us.
chapter 9 is on
I
the
ain't
paper,
reading
like
all
they
that.
emphasize it a lot. Or
You guys, it's not on there at all.
I know.
For them, it's 20+%.
I won't be here.
These people are crazy. The AP, like, they're
I
used
still
to
won't be here Friday.
statistic models.
Okay, so doing the wrong thing.
I'm good. I'm not. This is
I'm
really
doing the wrong thing. 7.2, I want 7.3.
I said that.
Okay,
Friday,
I know, areas of circles, like it should be easy, yeah?
We have to do proofs.
Sorry. What is the discount? Oh, I have, I know something tomorrow that I need to watch that. Also, I won't be here.
It's totally me.
I like that. I like that rather than dance club because those are kids. Also, I won't be here Friday. I won't be here Friday. For their age, they were really good. Very good. Like competing every week at like 10 years old.
That's insane.
And competing well at that.
Wait, is the height of the equilateral triangle also one of the tests have to?
How do you find the height on an equilateral triangle? Good freaking question.
It's just root.
Pythagorean theorem?
One half.
No, but like.
Okay, guys, Carmen, what are you saying?
If you put a line down the middle,
Oh,
you can divide
bisect
one
it.
of the sides by 2.
I remember doing this. I remember doing this.
So was it how? Okay, Asher, she set you up. Now finish. What's the what with this?
2x squared plus h squared equals 4x squared.
I did something wrong. I wrote what he said, but I did something wrong.
Well, you have to solve it.
Oh, no, parentheses.
It's 2x times 2x.
So 4x squared.
So this becomes 4x squared plus h squared equals 16x squared. Do I divide? Do I subtract? How do I subtract? So it's 12x squared. Oh, this is gross. So square root, do I do plus or minus, or is it distance and I just want the positive?
Positive.
Just the positive. What's the square root of 12?
2 root 3.
2 root 3. How did you do that?
I just did 4 times root 3. So root 4 is 2, so it's 2 root 3.
Okay, square root of 12 is 6 times 2. Not helpful because neither one of those is a perfect square. 12 is also 4 times 3. 4 is a perfect square. Square root of 4 is 2. So, Natalie, what are you going to say?
Do you even have to do the Pythagorean theorem? Because isn't it just like the 60, 30, 90 triangle? Where
Okay.
because it's just like 1, 2, root 3 is a long, non-hypotenuse.
So, equilateral triangle. All the corners are 60 degrees because equilateral is also equiangular. 180 degrees to share among 3 angles. 180 divided by 3, everybody's 60. Right, Morgan?
What?
Yeah. How doing? It's Monday. It's like the longest Monday. And next Monday is going to be worse, but it'll be okay because Friday, we don't have to be here.
How's Monday gonna be?
Mondays are just forever long. March, I hate all of March. Basketball's exciting, but I hate all of March.
My birthday.
March is actually pretty good.
Well, happy birthday, and you were born in a cursed month. No offense to you, but
Dang.
all right. So, what Natalie was saying, 30, 60, 90 triangles, if you remember, the guy across from 30, the one across from 60 is root 3 times that. Just maybe a useful thing to know. But Isaiah, how do I get the area of a circle with the radius x over 2? Okay. So what is which becomes
X squared over 4.
and don't forget pi. X squared over 4 times pi. Okay. The area of an equilateral triangle is side length 4x. I was nice to you. I chose something even. So the base area of a triangle equation. Jacob, what's the area of a triangle?
Base times height divided by 2.
Okay, so Safal, in this triangle that we drew over here, based on what Carmen told us to do, what's the base? 4x. What's the height?
3x.
And divide that all by 2. So what do we get?
Get 6.
Wait, but aren't there?
Oh,
Half base times height. This was the entire base, right?
Oh.
And this is the height. So I do still want the half. So those 2's reduce. 4 root 3x squared.
Wait.
No?
Maybe 4x squared root 3. Is that different?
Okay.
Like, because you're just multiplying them. Yeah, that's what I.
kind of weird to stick the
Wait,
numbers
what
in the
if
back.
you, wait,
You can
why is
multiply
it-
in any order, it's all good. They're all right. Eric?
why isn't it 4x
Because it doesn't want to be.
root 3x?
Okay, because multiply the x to the x, okay? Like this guy here, combine him with that guy there. Don't be like, well, how big is it? It's x times x times x times x times x. Don't do
Wait,
that.
why is
Call it
the
x to
x
fifth.
not inside of the root? That's my
Oh, because it isn't.
But why? I'm sure
Why?
it isn't. I just
Okay.
think you could clarify.
Because when we were like trying to figure this out, be like, I don't know. I do the square root. I do the square root. What is the square root of x squared?
X.
X.
Oh,
Square
so
root
it
is
comes
gone.
out. Okay.
And
makes
then that
sense. I
square
got
root of
that.
12 is still there, and Asher's like, oh, we can pull that apart.
I got that. That makes sense to me now.
Okay. Logan, what's the equation of a circle centered at the origin that has a radius of 1?
H squared plus A squared equals 1.
H squared?
SAT.
Oh, X squared.
Isn't it like H minus K?
Okay, so if it's not centered,
Oh yeah, that's good.
It's
That's
in the
zero.
origin.
But I mean, yeah. It's x squared plus y equals r squared, right?
okay, this one. Yeah?
It's centered at 1, -5.
So the opposite of what thing's in there. What's the radius? 4. Radius, I changed it. Sam,
I
you,
didn't look
you
up to
looked-
see the.
you look down, I put a 6 on it. So, and the radius of this one is the square root of that guy. Okay. Why is this at all relevant and important? Well, the Play-Doh problems that I am promising we'll be doing. And do the Delta Math. I would like to give you a Delta Math exit card for one problem from tonight's homework tomorrow.
Is that different than what last Delta Math accidentally posed to us?
Probably.
So do the delta math tonight.
Do the Delta Math tonight. Wink, wink, nudge, nudge. Do the Delta Math.
Okay. I'll put it in.
Okay. So to show you what I mean by these problems, the wording on them is horrible. So we will describe some solid that has a cross section. We'll be like, oh, how about squares? We're gonna have squares popping up out of a space.
Consider a square.
So cosine does this. Y equals x squared does that. So I call them Play-Doh problems because I'm like, oh, let's pretend this is the little cookie cutter thing and the Play-Doh's coming squirting out of it. And all the shapes that come out are squares. So this is going to be a square. And yeah, okay. The image doesn't. Okay.
You just
Okay.
mean it goes up in a straight line?
All right. Judgy
Okay,
people.
I get it. Oh, it's square,
I get it now, so they're going
but it's extruded to the same height.
Okay. Judgy people.
Is it extruded to the same height or a changing height? I feel like it's got to be changing because otherwise we wouldn't calculate.
Okay. So here's a square, okay?
Yes.
And if I move the square of
Oh,
do you guys
not
see
a
like
rectangle. Okay,
the
got it.
dimensions of the square are changing as they go between the curves, but it's still a square. So if I said, you know what? We're going to have a thing squirt out a whole bunch of squares and it's going to make a solid. You ready? Okay, wait, I need to move this over here. The shape that it's going to look like is this like ridgeback fishy thing. So you want to find the volume of the ridgeback fishy thing. Okay. So, all right. Finding the volume of that weird shape. That's what these projects were for. Like, it's just a semicircle, no big deal. Well, this side of the semicircle is smaller than this one, but if I find the area of every little slice, like I will eventually find the volume of this egg that I lost part of it. But like this is bigger. I know it wasn't supposed to come apart, but it fell apart. I'm like, cool, look, here's a little semicircle, here's a bigger semicircle, and a bigger one. But the idea is cut it into little slices and add the areas of those little slices. That is called integration. The dx that we are integrating with is the skinniness of the slice. Ananya?
How do you find like those up? Like I don't
Okay.
understand.
Okay, I'll show you. So let's say this was our thing, and I only want it from 0 to wherever it intersects. And I don't feel like finding where that actually intersects. It's like 1.4 something, I don't know. So, area of a square. Carson, what's the formula for the area of a square?
Length squared.
Length squared. So what is the length of the square? It goes from the top curve to the bottom curve. How do I find that length? Amalia? This equation was y equals cosine x. And this guy was y equals x squared. What is the length between the top curve and the bottom curve? Yep. The length is top curve minus the bottom curve. So then, what is the area of the square that I need to then integrate? Carson said it's the length squared. Okay, this is going to look ugly, but there it is. That's the area of the square. Am I finding area, or when I integrate, am I getting a third dimension? Third dimension, it's getting a thickness, it's getting volume. So the setup of this is 0 to whatever that intersection point is. Of that area. Does that make any sense?
The area of the object we have tried to find needs to be even.
What's that?
So can it be like rectangles and stuff, or can it
Yeah.
only be-
Oh, yeah. They can do all kinds of things. They could make it circles. If you cut all the little circles, this is a cone. We could find the volume of a cone using the cone formula, or the way they developed it was they used stacking circles. Yeah. You need to know the shape formulas, which is why you guys had that delta math a while ago. But so here, somebody's having too much fun. All right. Yeah.
How did they get to that height? Like how do I know what height the
Okay. This one, this image that you see right here, they said these are equilateral triangles. So what is the height of the triangle? Well, we just did the various, like, you could have done Pythagorean theorem to find it, which this is going to get ugly because it's top curve minus bottom curve is the length. So half of that length times root 3 is going to be the height in an equilateral triangle. Okay. Let's try a real problem. So the steps to solving these. First of all, try and draw at least one cross section. Like, did I tell you it was a semicircle? Did I tell you it was a right triangle? Did I tell you it was just a square, friendly old square? And then you need to know the two-dimensional area formulas. So pi r squared is a circle. What's the area of a semicircle? Half that. Area of a square, area of a rectangle. Rectangles, I'd have to tell you the dimensions. And then find the limits of integration and then actually integrate it. People are writing the steps down, so I will wait. Morgan, you haven't written anything. Yeah.
It distracts me.
It distracts you. No, you don't have to write. We're going to find the volume of a croissant.
So when you like use this
So,
board
Ms.
in
Pesca,
real life?
how is this work?
Yeah,
How do you put it in here?
exactly.
You have a Casio? I have no idea. Or you have
No,
an
it's not.
HP?
Yeah, it's ridiculous.
TI 93? What is that?
Inspire.
Consultation so that you don't like lose
It's inspiration.
Uh-huh.
So here's
Maybe that's a
another.
good question.
That's not a.
There's that cool thing, but
Do we get a lot of like fishy shapes in this?
you might. So that's what the solid looks like. Sorry.
Make this happen on our calculators?
No, you cannot make this happen on your calculators.
Fun.
Though I did put the links to these up so that you can make different shapes. You can make it be a circle cross section and look at the kind of squished rugby football thing, equilateral triangles, and you can move the slice around and be like, oh, what's going on? There's the triangle in there. Whee! Woo!
Wait, what are we supposed to be working on right now?
Yeah, okay. Where do you? Well, I was waiting for people to finish writing, but I was blocking them. So we're gonna do this one. We're gonna do the croissant. So this is a horrible way they write these problems. A solid is made so that the base of the shape is the region between the x-axis. Already I'm lost, and one curve of y equals 2x. So that's they're first describing the little cookie cutter print that these shapes are squirting out of. Okay, so we have the x-axis and one arch of that y equals 2 sine x. And then they explain some stuff. Every cross section, so cross section is a slice through the shape. Every cross section is cut perpendicular to the x-axis, which, what does perpendicular mean, Liv?
It creates two right angles.
Makes a right angle. So perpendicular to the x-axis. So the slices go this way, and that right there means a dx thickness. They can make them go the other way. So be careful. So that's a dx thickness. And every shape that pops up is a semicircle. All right. So what's the area of, Lana, what shape am I finding the area for? Semicircle. So what's the area for a semicircle? Pi squared over 2. Okay. Do I know the radius? Francesca? I know diameter. Okay, what's diameter? As an equation, what's the diameter? Because the diameter here is different than the diameter in the middle, which is different from the diameter on this part. Diameter is 2 sine x minus 0. So it's just 2 sine x.
It's dy.
Is it dy?
Oh, no.
Yes. So if the radius is 2 sine x, the diameter, what's the radius? Just sine? Okay. So Sydney, what is the area with all the formulas mushed together that I need to integrate? Any single cross section is going to be this with that radius plugged in.
It's gonna be 1/2 pi sine x squared.
Okay, what are the bounds of integration, Francis? Okay, well, the little croissant thing is squished in here. What are the bounds looking like they are?
0 and
Okay, 0 to pi. Can I pull this 1/2 pi out front? I don't have to, but can I? Yeah, okay. So type it in on your calculator, see what you get.
Why did you leave the 1/2? You took out 1/2.
I get pi squared over 4. Check. What is pi squared divided by 4? Did it match?
Yes, I got it. Yeah, I got that.
Okay, they're not gonna ask you to do this, but you just can't integrate sine squared. You need to change it. I teach pre-cal, so I'm really familiar with these formulas. So if I ever need to turn a squared thing into a not squared thing, I know the cosine double angle formula. I solved for sine squared, and I took out sine squared, and you guys asked, I asked actually, can I move that out? And you said, yeah, you can do that. And typing it in on the calculator was no big deal to keep it in or out, but integrating it with the other stuff, it was just a mess. So I moved it outside, and I integrated this thing. The integral of 1/2 is 1/2 x. The integral of negative cosine is negative sine. Stuff inside stays the same. Chain rule, divide by the derivative of the stuff inside. Now evaluate from pi to 0, plugging in pi, sine at 2 pi, poof, goes away.
Wait, so you went from
I integrated and I integrated each individual
so you
thing.
went from sine squared to cosine double angle?
Yes. Because I can integrate cosine 2x, I can't integrate sine squared. So I swapped out using some trig identities. And no, I've never seen them ask you to be able to do that. Just
Can
showing you.
Roll up a little bit. I'm really just to see kind of how we got there.
So would this actually mostly be calculator problem?
Yeah, this is probably a lot of calculator problems. Though areas of squares, easy enough to integrate. But if you, what was the decimal, Ananya, that you got?
0.46.
2.468. And what's the next decimal?
Oh, I didn't round it, but 2.46740.
2.467.
40.
So this would actually be wrong.
Oh, you're right.
Truncating 4.67, rounding 2.467, 2.468, all that work, and they take that point away.
I
Yeah,
wrote
what do you mean?
2.467.
Okay,
So
so
is this all finding one slice?
so this was one slice.
One slice, right?
That was the area of one slice, and then I needed to find
At
all
arbitrary
of
point.
them, all of the skinninesses. This is the dx. Find the volume of every skinny little slice like these guys in the circles. Find the little white circle here, the little red circle there. Isaiah?
Why aren't we integrating like two sine x first to find the area of what we're doing?
Okay, 2 sine x is not an area. 2 sine x is in length only. This distance from here to there is a length. I wanted to find the area of the whole semicircle. okay, so that length was actually a diameter. Cut that in half and get our radius so that we can get a formula for that disc, that
So we just
semicircle.
found the area of like 30 meters.
Wait, so we're
Clear. So we found the area for just one cross section. This one cross section. And then we found the area of this other one. This thickness guy.
So we don't know what the area of like the finger length,
We don't know what.
like the curve or length.
That's the area of any one skinny little slice. And saying integrate it from 0 to pi, here's the area times the thickness. And I'm taking really skinny slices and I'm adding them all together. And then they plump up to be one fat croissant. So you're concerned because we didn't take that into account? That's what this is doing, the integral here, saying integrate from 0 to pi, do skinny little slices all along and add them all up. No? Kinda? Yep.
We're just like finding the total area from 0 to pi and finding the volume.
We're finding the volume by integrating the area from 0 to pi. Yes. What?
area.
The integral of area, you're adding one more dimension, gives you
And how thick is each slice?
how thick is each slice?
like
It's
infinity.
dx thickness.
So like a small circle.
Itty bitty skinny. Like if you've seen a big rectangle of papers, it's called a ream. It's 500 sheets of paper. I would tell you the thickness of a sheet of paper is 0.
So those aren't actually integrated to be like that thickness. They're just
These are models. So the things that are all around the room are just they were told to make thicknesses of a 1/4 inch or less, and then they had to find the actual calculate the volume of all these little cardboard slices versus the theoretical of how thick it should have been. Yes. The most hated project I've ever assigned. I will never assign it again until this one never doesn't work anymore.
Let's like it next year.
Most hated project ever. Okay, this I don't want to do. Just reading the question is hard. Oh, that one's hard too. Let's try a different problem. Okay. What's our footprint gonna be?
Find the volume of solid beams.
Base is what?
Circle with radius.
Okay, fine, we'll do that.
Oh, no, yeah.
Oh, cross sections. What should we make the cross sections be? Triangles? What kind of triangle?
36.
Okay. Asher is asking for it. There you go. There we go. We'll try this problem. So, first of all, the reason I asked the warm-up, Logan again, what is the equation for a circle radius of 1 centered at the origin? X squared plus y squared equals 1. Let's see. Okay, so x, y, radius of 1. Slices are 30, 60, 90 right triangles, and the small leg is on the cookie cutter sheet. So this is the small leg of the, perpendicular to the y-axis. So that's this way. We drew them the other way before. perpendicular to the y-axis. How thick is
Wouldn't
this?
it not matter because it's a circle?
It doesn't matter because it's a circle, which is why one of the reasons I didn't want to do this one. But to be accurate with how they wanted it set up,
So the height would be root 3.
here's my triangle. The height would be root 3, is it?
Yeah.
Well, it's going to be root 3 times whatever this side is. What is the length of that side? And
1.
hang on, no, it's not 1. It's 1 only right here. Well, that's actually right here. It'd be 2, length of 2, because a radius of 1 this way, a radius of 1 that way. This is dy. I need the equation in terms of x equals, with all this stuff, it's a y. Yeah?
X equals minus y.
X squared
Because x squared equals 1 minus y squared.
So x squared equals 1 minus y squared, so x equals. All right, this is Asher, I'm blaming you because you're available. This is what I do. This side of the circle is x equals positives. Okay, Sam.
I see y equals
1
Oh,
minus y
X.
squared.
X. Sorry. So positive x's are over here, right? And that's positive x's square root of.
Oh, we have to do 2 bit.
No, you don't.
4.
No. But what is the length? What is the distance from here to there?
Absolute value.
Right minus the left. The length of that small side is
It's the integral of that.
right minus the left. It gets easier once this cleans up. How did
2.
2 of those minus a negative? Whoo, goodness. But at the beginning, you
Why
got
are we doing this based on the y, the x, not the y?
sorry.
Why is it x equals, not y equals? Is that just arbitrary?
No, because they said they want the slices perpendicular to the y-axis,
So
and it
it's
does not matter on this one because it's a circle. But on everything else that you're going to do, it's
So
going to
it's
matter.
root 3 times that, and then the integral of that from down.
So that's the height, but the area is actually kind of nice. 1/2 the base times the height, 2
Oh, I
times
see what you mean.
this, and 2 root 3 this. 2 divided by 2, the square root went away and it actually became something nice, but it half of you are glazed over and like drooling on your papers asleep. Yeah, sorry, Eric, March. It's a crappy month. What? Where'd the square root go? Well, I had a square root in the length and I had a square root in the height.
1 minus.
So square root of stuff times exactly the same square root of stuff. Isn't that just stuff?
Yeah,
The square root
yeah, that's correct.
canceled out. Okay.
So you integrate that.
Carson? Then we would integrate that from -1 to 1 or 0 to 1 and double it. This one was tricky. This is on Delta Math, so please try it. We'll go over more Delta Math problems yesterday. I didn't mean for this one to be as wicked as it was.
That's the first time I was like, oh, I can do this. And then
Yeah. So you will have a problem tomorrow on Delta Math.
If it's on Delta Math, can we not, like, do we get to turn in work and maybe get partial credit if we math?
Yes.
That's a good thing.
Yeah.